Today we're going to talk about ozone depletion. In order to understand what depletion of the ozone layer is, one must first understand what is the ozone layer. The ozone layer is an inorganic toxic gas of trioxygen. It acts as a protective barrier from UVA and UVB radiation. It can be observed as a pale blue color with a pungent smell. Ozone depletion is the destruction of the ozone layer. It is depleted when ozone-depleting substances, or ODSs, are released into the atmosphere. The 6 most common ozone-depleting substances are chlorofluorocarbons, or CFCs, hydrochlorofluorocarbons, halogens, methyl bromide, carbon tetrachloride, and methyl chloroform. Some examples of CFCs are CF3CFCl2 and CF2Cl2. Ozone-depleting substances are commonly found in foaming agents, aerosols such as hairspray, and pesticides. So, in the case of a CFC, what happens is UV rays break the bond between a carbon and a chlorine. The chlorine then breaks a bond between 2 out of 3 of the oxygens. Because trioxygen is toxic and highly unstable, it readily reacts with the chlorine. The result is a chlorine bonded to an oxygen and 2 oxygens bonded to each other, also known as plain old oxygen. Commonly, a floating oxygen will then come in and break the bond between the chlorine and the oxygen to form another oxygen atom. The lone chlorine then repeats its job up to 100,000 times, breaking more ozone molecules. The overall result? A hole in the ozone layer 100,000 times the size for every chlorine or bromine released into the stratosphere. An increase in UV radiation, which increases the risk of skin cancer, a higher chance of developing cataracts, and a lower human immune system. One of the more alarming and relevant consequences of ozone depletion is the melting of glaciers. Let's stop ozone depletion before it stops us.